framework using Godog, and then Utkarsh regarding the setup, and finally Ashutosh with respect to Swagger.
Hi, this is Ganesh. I'm giving a talk on BDD testing using. So the introduction is about, it's more like software testing. So everyone would have heard about like TDD, it's like test-driven development. So your code should have proper unit test. It should be modularized enough is what we hear often. And what actually is the problem with TDD? So TDD will not cover the actual behavior of the system. So don't cover the functionality, exact functionality. It covers the software modularizing, software writing practices. So in that cases, it's better to go for TDD. And it's like more specific who's actually getting benefit from TDD is like the developer, the programmers are getting benefits. So the end user is not going to get any benefit out of TDD. So to solve this problem, we are going for something called BDD. It's more like we are concerned about the functionality of the system. So can call it like a BDD is TDD done right. So, and BDD uses natural language. So natural language in the sense, a simple sentence, you can say English sentence. So we want to project the functionality in a simple language to the end user, and he'll be able to run with the help of the simple language. We don't need to provide a software binary separately and documentation separately. So it's like combined, it's a third approach. It's a hybrid approach. We'll be providing both together. And the introductions, like I'll cover a demo of using Godog with which is actually a BDD library written for Golang. So developers here will be working on writing the user stories, generate test code, and running the test code. But the stakeholders or the end user, they only care about the user stories. They don't need to care about the test cases. So that's actually the purpose of going with BDD. And we have planned to use this in integration testing. So need for BDD. So as explained before, I'm just extending it here. So I'll be automatically generating a test code based on user stories. And I need to plug in that with my function, business logic function. That is how I have to do from a developer end. So if I need to combine this together, it needs some additional tasks, right? So there is something like we are going to use a framework, use a library, which will automate that task. So that's actually the Godog library, which I'm talking about. And it will reduce the learning curve, time and effort trying to write our own plugin. Yes. We need to write the glue code. So we call it like a glue code to map the behaviors to implementation. So here it's like that's a tedious effort, and we need to handle our own error cases, and it will be different everywhere. So this Godog is going to be like a generic framework which can be used in all systems. Syntax of the user story will be like given what and under what circumstances, when, then what should be the expected outcome. So in unit test cases, we'll be like, we are more concerned about passing unit tests. So the test case should pass is what we think. But in integration testing, we don't need to consider like it should pass. Of course, the functionality should be passed, but it's like a testing at the end user, whether this functionality is supported by this organization or not. I'm more concerned in that way. See, we are working on something, we may not, we are working on Kubernetes, we don't support Docker Swarm as of now. So if an end user is going to try our product on Docker Swarm, he might not have read the documentation. So you can just try like, okay, this doesn't work. It will be showing failure. So we are not concerned about the result, rather we are concerned about the functionality or the behavior. So the name BDD. So I'm just giving an example of user story. So scenario 1, account deposit, given a bank account with a balance of $100, and the customer is going to deposit $20 more, then the balance should be 120 right now. It's a simple example. So we'll be following this syntax. Next one, how we are planning to use it. So there is something called C-store pool. It's like a virtual pool on top of a disk. You can take it. So the functionality is to create a C-store pool. So why we want to use C-store pool? Because we want to store data efficiently. We want to store and retrieve it efficiently. As a DevOps admin, I need to be able to create C-store pools. So scenario 1 is like, I've got create 1 out of 2, which means given there are 2 C-store pool requests, when I create one, then there should be 1 remaining. So I'll give a demo now. Let us verify.
Ganesh?
Can you hear me?
Yes, Ganesh, we can hear you. No problem.
Yes. Okay. So now I have run a test case, which is about to create a test C-store pool on top of a disk, and it says like test has passed, and it has 3 steps. So these are the 3 steps. So, and we can verify like the pool is created now. Earlier the pool is not there, and then now the pool is now created with my test code. So I want to check some failure. So let me run the same test case. It will fail because it's trying to create a pool, same pool on top of the disk, which is already available. Yes, now it has failed, saying like this disk is a part of active pool 1. So still the pool is available, and I'm able to handle the failures. So this is called behavior-driven testing. I'm not cared about the end result. I'm not cared about the test case pass, but I'm just cared about the functionality. So that is BDD. So I'll just do a code walkthrough of what we are trying to do. It will be helpful for developers. Yes, this is the feature, the user string. So user will be just having this, and we'll just run it. Yes. Here I'm mapping the same user string. Here I'm mapping the same user string to corresponding function. I need to handle the functions here. So I create function is going to create a pool, and there should be remaining is verifying the test cases. So this is a pool creation function. Yes. So how OpenEBS is going to support this functionality is what we're trying to, is what we'll be seeing now. So OpenEBS Litmus. So Litmus is all about Kubernetizing Godog. So as of now, we have seen Godog at host level. So Litmus will be like we are trying to Godog with Kubernetes, and it's going to have some other generic codes with respect to Kubernetes along with the user stories. So end user can debug his running test case written in language he can understand, which means it's a native language. And Litmus bridges two worlds, Kubernetes and the user. So it's so generic that it can be used for any application which is going to be plugged onto Kubernetes. And yes, so here we are doing a memorization. Memorization in the sense we are doing a string comparison. So user is going to write a string, and we are going to exactly match the string to a particular function, and we are trying to write it. So it's called memorization. So right now, Godog supports it. It's an initial stage. So Godog supports only memorization, string match. Yes. So Litmus feature requests or plans are like we are going to support auto debug of Kubernetes failure, and we are going to do a chaos engineering, induce a failure, and we should be our test case should be able to be handling that, and we need to report that to the user. So, and one more thing is like instead of coding the function manually, so we write the user stories and we code at the back end, right? So instead of coding it, we have some plans to integrate that with the CRDs, which means you'll be just applying a YAML at the back end, and you'll be writing simple language, native language in the front end. That's the plan. Yes, this is like a overall architecture or design. Here we are having the natural language augmentation engine, and we generate code at the back end. This is the front end, back end, and here I'm going to call my business logic. This is my business logic, and there is a matcher in the middle. That's a probabilistic matcher we call. So I just said memorization, right? As of now, this is like in initial stage. I'm just doing a memorization. Now we are doing there is something called probabilistic matching. So here we are in the previous user stories, we are saying like have a line, and we are exactly matching to a string, right? Here it will be like we don't need to follow anything, just write a sentence. User can write whatever sentence you want, and our program should be capable of matching that sentence to a particular function or feature. That's that should be like a feature request, we can say. Yeah. NLP along with memorization, natural language processing, like artificial intelligence concept. So we can think about it. So we can use this instead of or along with memorization. So natural language processing is like language augmentation. We don't need to memorize the strings. Instead, we have to train our program to adapt to the environment accordingly. So user can write whatever he wants, and we should be able to. I mean, we should be able to analyze it. We should be able to figure it out. So what are the factors we have to consider here? I just explained briefly, like we need to consider the grammar, articles, we need to find out similar meanings. And the stemming is like we need to find out the root meaning of a sentence. Say a user is going to explain in a very big paragraph, and we need to converge like what exactly he's trying to say. It's like summarizing grammatical structure, and we can use some open source libraries like OpenNLP, WordNet, like that. WordNet is like a bit popular for NLP. Yes, we need to make inference. That's the objective. Inference in the sense we need to find out the exact functionality what the user is trying to convey, and the reference can be like Godog, Cucumber. So they are like memorization. Smart BDD is a framework which is trying to do NLP in Java. So we need to figure out something like this. Yeah, that's it. So contributors are welcome to OpenEBS Litmus. And they can support and follow us in the Twitter links shown here. Thank you. Is there any question or doubt?
Hey Ganesh, Amit here.
Yeah.
So you mentioned about the C-store pools and you tried to test it using the Godog. What was the amount of effort you spent for executing that in Godog?
Amount of time?
Yeah, amount of time you spent writing the Go code that matches the Godog.
It's like half an hour, I can say, half an hour to 1 hour. I'm trying to understand what exactly is trying to do, and I need to write the program and refactor it. Everything has taken like half an hour to 1 hour, I can say.
Okay, thank you.
Yeah. If you are aware of it before, then it's like a couple of minutes. Just need to plug in the backend. Yes. Any more questions? Okay. Thank you. Now we are good to go. I think we can go with the next presentation.
So Utkarsh, maybe you can start.
Hi everyone, I am Utkarsh and hope you all are doing good. So we earlier had one session in related to OpenEBS logging where I have given some introductory session about EFK HA. So in today's session, I'll be giving demo. So this is a today's agenda. So as we have seen that Kubernetes pod logs are lost upon restart, and hence we need to have some tools that can
Utkarsh, you're not audible.
hello.
Sound is very less.
Okay. Okay. So hello.
Yes, it is fine. Fine now.
Okay, so we are here. So there was issue in Kubernetes when Kubernetes pods are locked.
Utkarsh, your voice is still not audible clearly.
Am I audible?
Yes.
So there was issue in Kubernetes when Kubernetes pods logs are lost upon restart. So we need to have some setup that can fetch those logs and stores somewhere persistently. So for that we will use Elasticsearch, Fluent, and Kibana, commonly known as EFK stat. So EFK basically Fluentd collects the logs from this where log containers directory in the pod, and it sends to Elasticsearch, and Elasticsearch uh, store it in some database with log stats, which is basically some, it basically store it in form of hashes so that it can be searchable easily. So here we are using 3-node cluster on GCE on GKE, and so this is some basic introduction about Elasticsearch, which is a search engine and that is responsible for storing logs. And so it can be deployed as a deployment or stateful sets. Only difference is that if you will use deployment, then you can roll back to the you can roll back, but if you will use stateful set, then you cannot roll back. You can scale up and go forward, but you cannot switch to your back state. So in Elasticsearch, during initial setup, it takes a lot of memory and CPU. So we can set it in the YAML file where we can limit those virtual memory max map count. So, and Elasticsearch is also multi-tenant. So I will talk about that in later. So in this HA setup, we will use the master node, client node, and data node. Basically, there are 3 concepts in Elasticsearch. One is master node, one is client node, and another one is data node. So master node is responsible for discovery and sard allocation. Client node is responsible for providing aggregation, and data node is responsible for storing the sards and does create read, update, and delete operations. So you can have multiple master nodes, you can have multiple client nodes, you can have multiple data nodes. So as per your requirement, you can scale the replicas as per your requirement when needed. So this is a basic introduction about Fluentd. Fluentd is an open source project which is used for collecting the logs, and it deploys as daemon set because you need to collect the logs from all the nodes. And okay, so in order to Fluentd to work, we need to have these annotations to be there. So otherwise Fluent daemon set will ignore them and it will not collect the logs from there. Kibana is a UI from Elasticsearch where we can visualize the logs, we can search for logs, and there are a lot of plugins already available for better visualization of Kubernetes. So it also deploys a deployment. And so in this setup, I'm using Node port. So this Kibana UI will be available as on Node IP and Node port. So you can use other ways to make it secure. So there are some problems and challenges with EFK setup, like scaling and managing Elasticsearch requires a lot of manual work. Like you need to reshard the nodes, and you need to rewrite the indexing and then scale it up. So there is a very good blog about it, which I have mentioned in the bullets. So basically there are 2 ways to scale. Either you can add the disk capacity to existing nodes, or reshard to add more nodes, or we can directly scale data nodes or client nodes. So these are in this setup I will be doing I will be using this master, client, and data setup. So you can, this will be a separate deployment. Each of them are separate deployment. So you can scale it later when needed. So we will move to demo. Basically these are some steps that have to be followed in the order, and you have to wait for each configuration to be available on the Kubernetes cluster. Then you will move to next step. So I already have that setup because this takes some time to fetch the data from all the nodes, and for initial setup it takes time. So I already have that setup. You can go through these steps one by one and you will be able to get the logs. So I will be showing the demo now. So you can see here, this is a Kibana UI. So I already have that setup. You can follow those steps mentioned there and you will be able to get these details. So this is what we are getting in the logs. So these are the logs. How you can set up that? You will get these things and you can set the fields from here. Say you want to have container ID, then container ID will be discoverable here and you can move it to there. So these are some simple steps you can follow to see the logs. You can customize it as per your requirement. So there are a couple of more fields are there which you can use, like state, status code, what is the state, and all those things. So you can see it. You can experiment on these things. This is not a tough things. So other than this, now I will try to deploy OpenEBS operator and see the logs. It will take some time because of network latency. Generate some logs. So now I will go to Kibana and try to refresh it. So we are getting these logs starting my API server, and these are the logs from my API server. You can see here one by one. So we can remove it from here. So here you can see each of the logs which are there in the my API server container. That are those logs are visible here. So we can customize it as per our requirement. So now I'll move to the presentation again. What we can do next, what I have not covered, is curator and multi-tenancy. So in curator, just like in monitoring, you set some retention period that after some times these logs should be flushed, and we can get the logs from that period of time, and after that these logs should be flushed out. So the same concept applies here with the help of curator. So you can search on Google. I will take another season for this and where I will discuss about curator. So how you can curate your Elasticsearch cluster, and you can flush your logs, older logs which are not required, and uh, the next concept is multi-tenancy. So multi-tenancy is like you have several Elasticsearch deployed on separate clusters, and then you can collect the logs from all those clusters, you know, at somewhere. So these concepts are very similar to master, client, and data nodes. So your master will be there, and your client and data nodes will be aggregated towards the cluster at many clusters, and those IP, the service discovery IP will be shared with the load balancer. That load balancer IP will be shared with master node, and then we can get the data from the other clusters. So this is how we do multi-tenancy. I will try to give a demo on this probably in a couple of sessions. So that's it. Thank you, everyone. I'm done here. Any questions?
I have a question, Utkarsh.
Yes.
So how are you collecting these logs? Like you'll be communicating with kubelet, or you'll be just getting the kubelet logs?
This is a very good question, Ganesh. If you can check, if you exec into the Utkarsh, you are not audible at all. Okay. So Ganesh, if you exec into the container, so you get the logs, all the logs stored in the var lib directory. I have mentioned in somewhere in the presentation. So here, Kubernetes stores container logs on var log containers directory. So here there are containers ID available, and if you go and cat var log containers, then you can get the data, you can get the logs from there. So what it does, Fluentd creates some copies those data, copies those logs, and it convert it to its own format, and then send it to Elasticsearch. Uh, I hope it clears your doubt.
Yes, it clears my doubt. Like here, you're trying to get container logs, your application logs, you mean, right?
Yes.
Is it possible to get kubelet logs?
So so we cannot get the kubelet logs because Kubernetes earlier versions of Kubernetes, the kubelet logs were there. They store it somewhere, but now they are not storing it. So that's why we can't get the kubelet logs. Earlier they were storing it somewhere, say syslog, and some directory was there, but they are not storing it now. So you can get the kubelet logs.
Okay, thanks, Utkarsh.
No problem. Any more question?
Yeah, so Ashutosh, you can start.
Hi everyone, am I audible?
Yes.
Green?
Yes, Ashutosh, yes.
Okay, so I'll talk about swaggerizing Maya server. So before I go any further, I'll discuss about what is this OpenAPI specification. So this is just a community-driven open source project, which is also collaborated by Linux Foundation. And this aims to develop something which is known as OpenAPI specification, abbreviated as OAS. It defines your REST API standards, how your API should look like, how will it behave, and how will it act, right? So what it aims to do is like OAS can be used to generate docs for API, or you can even generate a client or server using this specification. We will see how can we generate and how can we generate API server and docs for that. So this is written in a YAML or JSON format, which will again describe your API. So this OAS is nothing but an API description. So when it comes to OAS, what we hear a lot is Swagger. So Swagger is nothing but an open source framework that supports this OAS thing, okay? So Swagger also defined API specification, which was known as Swagger Specification 2.0, and until it was renamed as OpenAPI Specification 2.0 because of the similarities in their description standards, right? So Swagger consists of various tools which will help you to develop REST API according to the standards, right? And when we talk about standards, the question is like, why do we need these standards? So this is just to avoid the extra overhead to the user or to the developer. Like when I want to send an API request from a client to a server, I will be wondering what would be the payload schema or the response or things like that. So if we generate a beautiful docs using this OAS, and a developer what need to do is just see the doc and he can figure out how is the behavior of the API, what would be its payload schema and all. So that is why this standards has been developed and lots more standardized. Recently, we have also Specification 3.0. So the two most important tool that Swagger framework provides here is Swagger CodeGen and Swagger UI. So once you have OAS handful with you, you have an OpenAPI specification. What you can do is you can use this Swagger CodeGen, and this will scan your OAS and it will generate client or server, whatever you want. And what you need to do is just fill on those stubs or the boilerplate code that will be generated by this Swagger CodeGen. Write your business logic, implement it, and you are done. So yes, it can pace up the development. You need not write from scratch right here. So what about docs? So this Swagger UI, what this will do is when you have your OAS, the Swagger UI will consume this OS, pass it to produce a beautiful API doc. And even if you want, you can customize the UI to some extent, right? Then GoSwagger comes in picture. So what is GoSwagger? So basically, there are some limitations for Swagger. So the limitations are like the CodeGen tool that Swagger provides has very less support for Go-based projects, and as well as code generation method for this API and all is not suitable for existing project, right? Because you have written an OAS, you have described how API will behave or look like, and then you generate your server using this API. So it will just be completely different from whatever your code is existing right now. So that means you have to start again from a new point, right? And there is risk to break your client as well. Like you changed your specification, you upgraded something, and you didn't take care of that in your server code, so it can break you. So it really does not remind you of your how should you deprecate your API or about the backward compatibility. So the question is, so what should we do for existing projects? Does that mean that we should write our OAS, that is the spec file? So probably the answer is yes. To generate the API doc, all you need is a OAS. And obviously OS can do more as we discussed. But the main question here lies is how can we automate it? Like how can we generate this OAS? Do we need to write this OAS manually or can we automate it? So here GoSwagger comes in picture, and let us talk about this GoSwagger. So GoSwagger is just a framework like Swagger. Again, it is sponsored by VMware, and similar to Swagger, it also has a code generation tool, GoGenerator. But right now we talk that we want to go by code generation method, but still it also provides you a tool, and it has support for Go-based project, unlike of Swagger CodeGen, which is supporting greatly Java-based projects. Well, so what is the difference between this Go Swagger framework and Swagger framework? So this one at the moment actually works, and there are many limitations with this Swagger framework when I was trying to research on that. And again, this Go Swagger has very good support for Go-based projects. I will not say the documentation is great, but yes, it is better than Swagger one. So how does it solve our problem? So how can we have my API server, right? It is an existing project, so we do not want to generate again by writing the OS. So what we can do is we can use Go Swagger annotation. Again, it is a tool provided by Go Swagger from framework. So before I go about the annotations, let us give a look about the doc generation workflow. Here we have YAML or JSON. So YAML will typically get converted into JSON, and it will be consumed by your Swagger UI, and then the Swagger UI will pass it to produce a beautiful doc. So most of the UI will be able to consume YAML directly or JSON directly, but some of the UIs needs to consume the JSON only, right? So Swagger UI is just one of the UI that is capable of parsing OAS, and it is provided by Swagger framework. There are many more present there. One of the example is like Redoc UI provided by Redoc. It is also capable of parsing your OAS. So what does this Go Swagger annotation does, and what is it is you have certain defined tags that Go Swagger provides. What you need to do is you need to just write around your code these tags in specific comments, like you have endpoints, your paths, your methods, and you have some suitable tags and a structure to follow that. You can just annotate your source code with those tags, and done. Once you are done annotating, we have a Go Swagger CLI, and you just need to run a simple command like Go Swagger generate spec. It will scan your whole source code and will produce an spec file which is in OAS, right? It will scan all the tags, all the valid tags, and generate the proper key and the value that you provided in the comments. And Go Swagger also has embedded UI, which is Redoc UI. Go Swagger is not using Swagger UI, so it can consume your OAS to produce docs. And Docker Engine reference, API reference, that is also using this Redoc UI only. So I'll just walk you all through a quick demo how I have prepared a prototype of my API server. So is my screen visible?
Yes.
So this is the volume endpoint, and before that, this is a doc.go file. So what I have done here is I have annotated according to the Go Swagger syntax, right? Okay, before that, I want to show you what is this. This is the tag for Go Swagger, right? This is meta tag, route tag. So this gives you options and annotations, what all annotations you can use and what it will do. So I will just show through source code. So here I've written the schemes, right? Host, base path, and all the information that I need to provide for my API, what it will consume, what it will produce. And I have at the end written this Swagger meta tag. Meta tag is like it's all about API, right? And then what I have done is I went to this endpoint code, and here I can see there is put and post method. Again, we have get. So here I've annotated this. What this is a route, right? What what this aims to do is to create a volume. So here you have mentioned this as a route, this is a path, and this is a method, so this will be a post method, and this is the endpoint, right? And this specifies the name of resource, or you can call it as a tag, like right now it is a volume. For example, in some other projects it could be a container pod or anything. And this is the operation ID what I have mentioned here. So what does it do? It does create a volume. Again, what is consumes, what it produces is schemes, security schemes and responses, right? So the responses could be like 500 or 200 with attached proper schema, right? What happens when we get 500? So what is the schema for that? What kind of response we are expected to get? So this kind of thing. Similarly for that, get request. So whatever we have, get post, and that will be a route, that will be a path we mention in this comments. And then with that we have attached a response schema. So here I have written about the response schema. So now this is a Swagger response tag, and see this server error was mentioned there, here in this endpoint. So what is the server error? So I have written a struct which will be parsed by your Go Swagger and converted to the JSON schema so as to render in the UI. So what you need to do is just write a command like Go Swagger generate spec. Sorry. So it will take some time to scan through the code, and it will generate the spec file, and the file is demo.json here. Yes. So the file demo.json has been generated. We can validate also whether my specification is valid or not, whether I have annotated properly or not. So I'll write demo.json, and it says that Swagger spec is valid against Swagger specification 2.2. Now what we need to do is just do a Swagger serve using this demo.json, and it will produce a doc, beautiful doc right here. So this is just a prototype I have mentioned. So these are all are empty here. We can write here more about what my API server is, and here we have get request for list volumes. So what would be the responses? What does this list volume does? We have server error. What can we expect as a schema when we get a server error? So when we get a server error, it's like there will be some message, something went wrong, or kind of message that is provided by server. So this message is just an example one. It cannot be every time something went wrong. And same here is the response schema. So we have items, whether it is required or not, metadata required or not. So this way you can see properly here the response schema and all. So that has been generated according to that response struct, Go struct that I have written. And still we are in like discussion about this free forms, whether we need to mention this free forms right here in the schema or not. So yeah, that way we have post and whatever our MyAPI server supports, like when you want to delete a volume. So this way you can generate your API docs. So the same UI Docker engine is also using. I would like to show you. So this is the Docker engine UI, a reference UI. So they are also using the same way, the same UI. This is the Redoc UI. Okay, so now I'll move again to the presentation.
So, Ashutosh, can I like intervene just here?
Yes.
Okay, so I saw that the UI that gets generated is hosted on a local host, probably on your laptop.
Yeah.
Good. So I was just wondering, like the UI can on the right hand side of the UI, which shows the payload, right?
Yeah.
Can a user edit it? Is there any option of editing, or this is just a view only UI?
Yeah, right question. So this is a view only UI, right?
Okay.
You cannot edit here.
Mhm.
So this is just a prototype, right? It gives you an idea how this schema should be. So
Okay.
what you do is you annotate there right there in the source code with some of the examples. So what I have written here, this key is message and this value is just an example here, right? The same way you can see here is like labels. So what this property and just I was prototyping it. So this is named the OpenEBS volume. So I have provided this as an example. So you cannot edit here.
Okay. Fine. So I was just wondering. I mean, I have seen this kind of API docs for Kubernetes and other projects as well. I was just wondering, is it possible to get this entire UI,
Right.
running in a Kubernetes, and then
Yeah.
how about enabling users or one who is reading that UI, edit it and apply it to the Kubernetes? For example, when I want to create a volume, OpenEBS volume, I know that it's a Kubernetes command. Okay, so I just wanted to put click some button, and it will go ahead and create a volume in the Kubernetes in the Minikube or something where I'm running in. This will actually it will be a more live way of making the end users understand if they are actually working or not. This
Right.
was like my original intent.
Right. So to answer, so basically you've asked two questions. I'll answer it one by one. So the first thing is about hosting this UI, right? So yes, you can obviously containerize this UI. Okay. Right now, this Redoc UI, what I am using is embedded into this GoSwagger tool. We have it separate a dist available as a package. You can right there in your package manager. For instance, we have our OpenEBS docs, right? We can specify this UI doc, or we can use it as a CDN, and it will consume yours. So yes, you can use it inside your Kubernetes. Now your second question is how can we make this UI interactive? Like I want to create a volume on the fly. So for that, it can be done. That Swagger UI is doing it, but for that, this UI right needs to be a hosted solution. What I mean is like this Maya API server, uh, the UI that we are intending to develop is just for a reference, right? This UI and this Maya API server. Suppose I'm a user of Maya API server, so I cannot go to this UI doc which is hosted by OpenEBS and click on there to create a volume because I am using my API server on my own infrastructure, right? Does this answer your
Yeah,
question?
I mean, it sounds good. All right. So this leads me to another question, custom resources.
Mm-hmm.
Open will be having a couple of custom resources, and it may be a custom resource for Kubernetes. Okay, when you look from Kubernetes point of view, but when we look from the OpenEBS point of view, it's a very well defined schema that OpenEBS understands, right?
Okay.
How about having those payload and the schema in this UI in the Swagger UI? Is it feasible?
Mm, yes, if we talk about speed of development. So what this API doc is really going to do is it can help you reduce the burden of developers. And we are just an open source project here, and it's good to follow these open source standards, right? So what we are trying to do with this is just to provide a documentation for my API server. So whenever a new dev or anyone wants to understand, suppose I'm going to write something in OpenEBS provisioner or change something, so I must be knowing how this Maya API server act or react, right? So in that case, I need not go through the source code or wander around asking other, okay, how this request will be going on. What I can do is just go to the OpenEBS docs and this my API reference and just see this payloads and all, how this response samples are, and if I want to create a volume, what data in JSON I need to post, right? So this intends to do these things only.
All right. Thanks, Ashutosh. I guess this is fine for me. Yeah.
Yeah, thanks, Amit. Quickly walk through the rest of the slides. So now let us see, we have certain limitations of Go Swagger. One of them is because Go Swagger is still in development phase, so some of the keys of the OAS cannot be produced using Go Swagger tags. One of the example that I mentioned here is X logo. So what does this X logo key will be doing is like you can put on your company logo there in the reference doc. You can customize your UI using some of the tags in spec file only, but that tag will be available in spec file only once we have an annotation for that in GoSwagger, right? So GoSwagger solves this problem. What you can do is like you can, whatever is not supported, you can write it in JSON in a separate file and you can merge it while generating the spec file, right? And one can even argue is that even in GoSwagger, what we are doing is we are writing tags in the source code. So why don't we write our OAS itself? Why can't we write the spec document itself, right? And one more disadvantage I can see here is that the complex CI/CD process of this GoSwagger, right? You have my API server, you are sending a PR, you are making an endpoint, you annotate it. Now you will have to have some build script with this GoSwagger environment that will generate GoSwagger. Now again, there is a question, do we want to record this Swagger spec file or not? And then you can post it to the required infrastructure so as to get the UI. So yeah, this CI/CD is a bit complex here. And one more limitation I see is even if you change a single annotation, a single word, even a typo, if you want to change, it will generate the whole spec file again. And if our API server grows large, it could be like 2000s or thousands of line of YAML file, right? So this is one of the limitations. So then comes manual OAS writing. It can sound corny, but yes, Docker engine is using this. They usually manually write this Swagger .yaml OAS, but again they have shifted to project like Mobi/server. So I think they're generating their server code using this OAS only. I'm not sure what tool they are using to generate this OAS. So what they do is they will just manually update Swagger.yaml so as to get the docs. Okay, they are not using any annotation and things like that. And some of the advantages are like the CI/CD is simple. You just change your spec file, like, whatever is required, and raise a PR. So the CI/CD seems very simple here. And again, no environment setup in this case. You don't have any extra learning curve for the devs, right? And what you need to do is write spec, raise PR, and you are done. And again, the disadvantage, one of the great disadvantage I can see is like it can grow up, your OS can grow up large, thousands of line, and if you want to change somewhere, it would be hectic to change that big file, right? And again, it will not remind you to update the doc, right? So suppose I had changed my server and I am doing manual OS writing. So this is not the case when I'm writing OAS and generating the server. This is the case when we have a server and we have an OAS, but we do not generate the server using OAS. So we change some code in the server side and we forgot to like update in the OAS spec file, right? So GoSwagger basically reminds you the time you are writing your endpoint, you are there to write the annotation. So this is some of the pitfalls and advantages of OS and references I mentioned here. So any questions, I would be happy to answer.
Hi, Astos.
Hi, Utkarsh. Utkarsh, you are not audible.
I have one question.
Yes, Utkarsh.
So this only generates API docs, or it generates all the docs for your project? Like we have mentioned some comments or function level comments, some variable level comments, and all the comments are there. So it generates docs for that also, or it only generates docs for APIs?
Right question. So that comments, right, what we did there, they are preceded by a special tag, right?
Yeah.
So you have seen they have some special tag. So whatever is preceded by a special tag, so when at the time of parsing, right, when the code is being scanned by GoSwagger, it will look through those special tags and it will generate the docs for that only, if this was your question. And second thing is, like, if you talk about external docs, no, you can generate your API docs only. Yes, you can embed some external docs. You can provide links for some external docs right there.
Okay. Yeah, thanks, Astos.
Thank you, Utkarsh.
Okay, so I guess there are no more questions. Thanks all for attending this session.
Yeah.
Feel free to talk to us on our Slack channels, and we'll be happy to respond them. That's all we have for today's agenda. Thank you.
Thanks, Amit.